Well, scientific, well, scientifically speaking, no. But knowing about heat can tell you about temperature if you're clever. Temperature describes the average energy of the molecules in the system, while heat describes the transfer of energy between systems that are at different temperatures. Thermodynamics tells us how heat moves and its first three laws. 0. Heat is the same regardless of how it is measured. 1. Heat cannot be created nor destroyed. And 2. Heat moves from hotter to colder. Armed with these three laws, armed with these laws, we can understand how thermometers work. We can understand how thermometers work to make them. With these laws, we can understand how thermometers work to us. With these laws, we can understand how thermometers work to make With these laws, we can understand how thermometers work to make them as useful to us as possible. Consider the bulb type, that liquid in the glass tube thing you know and love. Consider the bulb type, that liquid in the glass tube thing you know and love. Imagine it's in the freezer. The thermometer loses heat. The thermometer loses heat. The thermometer loses heat to the surrounding. That means the molecules in the liquid slowed down, and the liquid contract, pulling its level down the scale. Move it over to the sauna. Move it over to the sauna. The thermometer. Move it over to the sauna. Move it over to the sauna, and the thermometer gains heat. This causes this causes the molecules in the, this causes the molecules in its liquid to move faster. This causes the molecules in its liquid to move faster. So the liquid expands and the level moves up the scale. When the thermometer is when the thermometer is steadied out, both it and when the sta- when puta. When the thermometer is steadied out, both it and the surroundings are the same temperature, which means which means thanks to term which means thanks to thermodynamics, the thermometer tells us what the temperature is. We've we've been playing around with this simple up-down thermometers. Ay, we've been playing around with the simple up or down thermometers for hundreds of years. What's up, Galileo? Fahrenheit and Celsius? Some clever physical some clever phy- some some clever phy- some clever physics and chemists and engineers have given us all kinds of thermometer you see today. So let's take a little tour. Many people associate trust Many people associate trusty bulb thermometers with the trust. Some people Many people associate trusty many people Many people associate trusty bulb thermometers with the mercury. Before we learned that exposure mercury exposure could lead to health problems, this liquid metal was preferred. This liquid metal was preferred because it expands and contracts at a constant rate and stays liquid over a useful range. In its sort in its sort of in and it sort of looks like the T1000, which is very cool, but finding silvery bulb thermometers is rare these days. That's not exactly a new that's not exactly a new trend, because even before mercury thermometers, some early adopters used red wine con- because its alcohol content protected from freezing, and it was easier to see in the glass than it was easier to see in the glass than quicksilver. Nowadays, most bulb thermometers use ethanol. This dyed red and sometimes blue. One of the most common electric one of the most common electrical is a therm one of the most electric one of the one of the most common electrical thermometer is a thermistor. One of the common elect One of the most common electrical thermometer is the thermistor. This is a resistor that conducts electricity differently as temperature changes. Thermistors are made from metal oxides like manganese, or say iron, or semiconductor materials like germanium or silicon, depending on the temperature range, and they're often embedded in a glass bead with wires. Sticking sticking out this can be made very low at sticking out this can be very this Sticking out this can be made at very low cost, meaning they're often what's inside the digi- they're often what's inside the di- there's they're often what's inside the digital thermometer that you might have stuck in your mou- that you might have stuck in your mouth recently. Checking if someone else has a fever. It's worth noting that electricity-based thermometers are still using thermodynamics, but using moving electrons or ay, but using moving electricity, gets us into the quantum realm. Gets us into the quantum realm. Quant, Gets us into the quantum realm. Sounds a little sci-fi. Sounds a little sounds sounds a little sci-fi. And check check out this action and distance options. Check out this action and distance option some metalloids are. If you don't know how to convert Fahrenheit to Celsius or Celsius to Fahrenheit, then you might want to finish this video. This can be a good knowledge about knowing how to convert Fahrenheit to Celsius or Celsius to Fahrenheit, because it helps you to know what the temperature is in different because it helps you to know what the temperature is in different is in a because it helps you to know what the temperature in a different kind of way. So that's so that is all for thermometers. Now let's go to solving or converting Celsius to Fahrenheit or Fahrenheit to Celsius.